Pluto is a distant and secretive, more humble planet that was once a piece of our nearby planetary system. However, recent disturbing announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a staggering revelation. They suggested that this viral world is on a potential brief trajectory with Neptune. Yet how might this, in fact, work? Also, what may be the outcomes of such a titanic event? Are we seeing a flabbergasting, limitless eccentricity? Or is there something else to this pushing toward a celestial incident? Join us as we examine the possible results of a Pluto-Neptune impact. Pluto, a former planet that was later renamed as a dwarf planet, remains a subject of interest and focus in the vast universe. As shown by recent studies by leading experts, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potential dangerous collision between these two planets, which could pose a huge risk to Earth. But how is such an event even possible? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even finished one full revolution. However, the interest doesn't stop there. Pluto's orbit is marked by its unusually elliptical shape, wandering widely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unique is its inclination, which is tilted at 17 degrees to the ecliptic plane. The way Pluto follows its path is significantly more tilted compared to other planets. This inclination and irregularity add layers of complexity to its orbital configuration. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, challenging what we would expect from their positions in the planetary system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to figure out its unique path. Unlike other planets, whose orbits lie somewhat close to the ecliptic plane, Pluto's orbit stands out with its steep inclination and elongated shape. The mystery deepened with the realization that Pluto's orbit crosses Neptune's. The stability of Pluto's orbit amid these complexities is evidence of the intricacies of celestial mechanics. The three-body problem in space involves determining how three objects, like Pluto, Neptune, and the Sun, move and interact with each other due to their gravity. It's like trying to predict where they will go based on where they started and how they pull on each other. In Pluto's case, this problem illustrates how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms non-synchronous libration and orbital precession, alongside the VZK oscillation, are key to solving this puzzle. According to astrophysicists, what keeps all planets in their orbits is non-synchronous libration. In the case of Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it is positioned about 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from merging. Orbital precession, on the other hand, refers to the upward movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is situated far above their orbital plane, offering an extra layer of protection from potential collisions. Another important factor in this situation is the VZK oscillation, named after three scientists, Zell, Kai, and others, who studied how objects move in space. It involves the way three space objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This gravitational force affects how they move. In Pluto's case, the VZK oscillation helps us understand why its orbit near the Sun is so irregular. Despite Pluto's orbit seeming unusual, this oscillation helps keep it moving smoothly over long periods. The VZK oscillation shows that, although things in space may seem violent and erratic, certain patterns and rules keep everything in balance. These factors help maintain Pluto's orbital stability, ensuring it doesn't collide with Neptune or drift off course. This three-body problem is essential to understanding how these orbits change. Because space objects pull on each other, studying this helps us learn more about Pluto, our solar system, and even distant worlds and their stars. Mathematical simulations in the late 1980s revealed that, despite these stable properties, Pluto's orbit is actually unstable, with minor deviations in initial conditions leading to massive differences over millennia. However, these characteristics in Pluto's orbit have been found to maintain stability over incredibly long timescales. Monitoring this disruption has been crucial. Later automated assessments helped us understand how giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This relationship helps keep Pluto's orbit stable. However, Neptune isn't the only planet involved. Jupiter's gravity also plays a major role in stabilizing Pluto's orbit, and Saturn contributes as well. These studies show that Jupiter's immense gravity is strong enough to ensure that Pluto stays on a consistent path for long periods. So perhaps Neptune, Jupiter, and Saturn are working together to ensure Pluto continues to move safely through space without encountering trouble. These quirks are crucial in maintaining balance and stability in space. Without these components, the solar system as we know it would be a much more chaotic place. Bodies like Pluto could collide with others or be ejected from their orbits, triggering a chain reaction with other celestial bodies. For Pluto, especially with discussions about it potentially colliding with Neptune in the future, understanding its orbit is essential. This provides a clearer picture of the dynamic nature of the solar system. The case of Pluto demonstrates how even the most seemingly unstable orbits can reach a state of harmony through the complex interplay of gravitational forces and orbital mechanics. It also highlights the importance of continuous observation and study of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the strange nature of celestial bodies. Moreover, Pluto's orbit is a perfect example of the eccentricity of orbital chaos, which refers to the delicate dependence of a celestial body's orbit on its initial conditions. This is clearly illustrated in Pluto's case. This means that even slight changes in the dwarf planet's position or speed can significantly alter its long-term orbit. Using computational simulations has been incredibly helpful for researchers in determining how Pluto moves in space. These simulations use complex mathematics to show how Pluto and other space objects like Neptune pull on each other. By tweaking small details in the simulations, space scientists can see how even minor changes can drastically affect where Pluto ends up. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. Despite having features like non-synchronous libration and orbital precession to keep it stable, Pluto's orbit can still be unpredictable and irregular. If you start with even a tiny difference in where Pluto is or how fast it's moving, its orbit could look completely different after just a few years. However, despite this chaos, Pluto's orbit remains stable over extremely long timescales, like billions of years. This essentially means that Pluto's journey around the Sun has a kind of order to it, even though it seems chaotic at first. Predicting celestial events, especially when they involve irregular orbits like Pluto's, is a tremendous challenge. The inherent unpredictability of these systems means that long-term forecasts are often filled with uncertainties. While mathematical models provide excellent tools for understanding and predicting the future behavior of celestial bodies, they also highlight the limits of our predictive capabilities. These models heavily rely on the accuracy of initial conditions, and any small error or distortion can lead to vastly different outcomes, making precise predictions a daunting task. Furthermore, the chaotic nature of planetary orbits like Pluto's reminds us of the ever-changing, dynamic nature of the universe. While we've made tremendous progress in understanding space, Pluto's case reminds us how much we still don't know about the universe. Understanding the gravitational effects of the giant planets on Pluto's orbit offers valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can significantly affect the stability and direction of other bodies within the system. So why are leading astrophysicists lately raising concerns about a potential collision between Pluto and Neptune, despite all these complex forces working to prevent such an event? Neil deGrasse Tyson, a prominent astrophysicist and a key figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, particularly the fascinating case of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, provides insightful views on the evolving nature of celestial mechanics and the public's interest in the overlooked domains of space. Tyson's stance on Pluto's renaming is based on the ever-expanding knowledge of our solar system. He sees the renaming not as a diminishment but as a significant adjustment in alignment with our growing understanding of the many bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and change. He views the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The fascination with these questions keeps space exploration so captivating. However, despite Tyson's confidence, his thoughts on Pluto's potential impact with Neptune paint a different picture. His concerns about the future of Pluto's orbit suggest that there may still be some mysteries to uncover. Will Pluto crash into Neptune? Or is this just another moment of confusion in the constantly evolving universe of space? Only time and further investigation will tell. For now, we are left with a deeper curiosity about how little we still know about our own solar system. We continue to explore these celestial phenomena in the hopes of uncovering more of the mysteries that lie beyond. The possibility of a Pluto-Neptune collision raises another question about the mysterious and fascinating universe in which we exist. The potential for an impact between Pluto and Neptune raises intriguing questions about the dynamics of the solar system, as it challenges conventional understandings of planetary stability. The idea that two celestial bodies with such vastly different properties could collide is both disruptive and captivating, especially considering the current relative strength of their orbits. Given that Pluto is situated in the outer reaches of the solar system, far from the major planets, and Neptune is itself a gas giant with a strong gravitational field, the implications of such a collision would be enormous for our understanding of gravitational interactions and the evolution of the solar system. To grasp the dynamics of a potential impact, one must first consider the structure and properties of the two planets. Pluto, despite being a dwarf planet, contains a variety of elements and compounds believed to exist in a frozen state due to the extreme cold of the outer solar system. Its surface is covered in nitrogen ice, and it has an atmosphere made primarily of nitrogen, methane, and carbon monoxide. In contrast, Neptune, a massive gas planet, is primarily composed of hydrogen, helium, and other lighter elements with a deep, thick atmosphere. A collision between such disparate bodies would radically affect their structure and behavior, potentially creating an event visible across vast distances. What makes this theoretical collision especially intriguing is the influence of other planets and bodies in the solar system. While Neptune's gravity plays a dominant role in maintaining Pluto's orbit, it is not the only factor at play. The presence of Jupiter, the largest planet in the solar system, is another key element. Jupiter's immense mass, powerful gravitational field, and gravitational pull provide a stabilizing effect on Pluto's orbit, preventing it from straying too far into Neptune's territory. Additionally, Saturn's gravitational influence further complicates the dynamics of the outer solar system, making it unlikely that a catastrophic event will occur between Pluto and Neptune.